Hi, folks. Welcome to another YFTT. Again, it's a talk by engineers for engineers, and it's like very focused on demos and practical considerations. Today's topic is about best practices using sequences, and I have with me Frank. Frank has been on the call on this talk multiple times, but anyway, Frank, why don't you quickly introduce yourself, and we'll get started.
Yeah, so I'm developer advocate here. So of course I'm testing features. I'm discussing with users, and I also met physically many users in Asia. Last month I traveled to Jakarta, Singapore, India, and Japan to meet the users. We had also had a meetup there. So the goal is sharing knowledge, and I don't see comments yet, but I think we can start.
Yeah, we can start. So again, guys, if you have questions, just feel free to post them as a comment on LinkedIn, or again, join our community Slack, yugabyte.com/Slack. Okay, so yeah, let's get started. Frank, tell us about.
So the idea is to talk about sequences, a basic SQL feature, but with some consideration to get scalable in a distributed SQL database like Yugabyte. So first, the reasons to use a sequence. Basically, the goal is to retrieve a unique number to be used for a primary key, for example. And using a sequence when we don't want a UID, because the UID can be longer to generate, can be larger as a size, or just because people are used to sequence when doing their data model. The thing with sequence is that they are generated in sequence, because that's the easiest way to get a unique number. If you always increase, you will never get back to another number. And then apparently it is always increasing, but we are dealing with SQL transactions, which is a bit more complex because they can be rolled back. So even if you see increasing numbers, at some point you may miss some numbers because it was rolled back. And also transaction can be reordered to be serializable. Two transactions that happen at the same time have to be reordered in one way and the other. So if people accept that the number follows the way it was committed, it can be different. And also we will talk about the cache. Without a cache, sequences are not scalable, and then the best practice is really to consider a sequence as a generator for a unique number, and nothing else, not expecting more properties from that. Basically, if you expect a number that is always increasing, it's that like this old device where it works only if you have only one, and then you cannot scale.
Yeah. So just to recap, right? Like, so this is sequences across all relational databases, right? Nothing specific to YugabyteDB, and specifically YugabyteDB and Postgres work similarly, but what you're saying is true of everything, right?
Yeah. The thing is, when it is distributed, it just increases the problems with the scalability. But even in any database, having many sessions reading the same sequence will always be a problem at some point. So basically, the first problem is that the last value to be incremented must be stored somewhere, like in a table and in a single point to be consistent. And then the solution is to cache it so that you do not read and increment the value each time you want the next value. When you get the next value, you increment it, let's say, by 100, and then you can use 100 number before going back to increment it. And this is a cache, and that exists in all SQL databases. The first problem is that in Postgres, the default is 1. So the recommendation is to have a cache, but by default, you don't have. Easy to solve. You can create a sequence mentioning a number for the cache. With create sequence, of also if you use generate a generated ID in the create table. But the next problem is that when people move from Postgres to Yugabyte, for example, and they use the defaults, then in the pgdump, it will explicitly mention cache 1, and then they may experience problems. So for that, we have decided to set a minimum default by default. That's a parameter when we start the cluster, the cache minimum value that we set to 100 for by default, so that even if you import a pgdump with cache 1, we will use 100. It's good to know if it can change if people do not expect gaps in the sequence. Just good to know. It can be set to 1, but then can have a scalability problem. So basically, if it is set to 100 like the default, and I want to create a sequence with cache 1, I will have a message telling me, no, it will be created with 100. And let's look exactly where the sequences are used. So to show the contention here, I'm not using the default 100. I'm setting the default to 1 so that I can create a sequence without cache, because my goal is also to show where the problem is. So I'm creating a sequence explicitly with cache 1. And if I describe the sequence and look at the catalog view PG sequences, I can see my sequence, and the cache size is there with 1 because I've set that to 1. Actually, PG sequences is a view. The internal catalog view is PG sequence with the same information, of course, just OIDs. And there we can see that we have a relation ID for the sequence, because Postgres consider a sequence as a table. Actually, if I can explain a select from the sequence, this is not a table, this is a sequence. I can explain it, and I can see a sequential scan on a table. This is how Postgres stores it. So I can select it. And what is stored in the sequence is the last value. It's a bit more complex because it's stores a Boolean to know if it's called or not. Basically, sequence starts with 1. The next call will get the value 1 because it is the first call, and then it will be set to isCall equal true to get the next one. So that's the Postgres implementation. We did it a bit differently in Yugabyte. Let's look. So this is the container I have started. If we look at the tables, I have no user table, no indexes, but I have some system tables there. And I have this PG sequence all in the databases. And we store all sequences in one table, sequence data. That's different from Postgres because we can scale one table. We need only one row per second in this table with one tablet. And basically, this is where there is the last value and the is called. But that means that the sequence is stored in one place, and that's where the scalability can must be considered. This place may be a specific region in a multi-region deployment, so that you don't want to hit this tablet each time you need a new number for an insert, for example. And just to show, so if I select from the sequence, it was initialized, so last value is 1 and never called. The next call to next val gets this value 1, but as set, the is call to true, which means that the next call will increment the value, get 2, and has incremented the value. This little trick with is called is just there for the first one.
So one question, Frank, it's a question from Piet, which is, if somebody forgets or accidentally runs with cache value too low, is there a clear indicator that explains the slowness if it occurs, like wait time or time indicator, something on the explain or some way to figure this out?
Yeah,
and
that's really
later. If you have that coming later, we'll wait.
Yeah, that's a really good question. Usually when we look at the hotspot, the tablets that are hit too many times, then we will see this sequence data tablet. I think that's the main place where we will see it. Yeah.
Got it.
Exactly like if there is many session updating the same row for a table. Yeah.
Got it. Got it. Yeah.
So actually, when we call nextVal with the name of the sequence, actually nextVal, the parameter is the OID of the sequence. So when we can call it with reg class that gives the OID for the sequence. And when we call it only with the name of the sequence, it is implicitly casted to the OID. Just to mention that when we call nextVal on a sequence, it's really on the object. And then I will run some pgbench to show when we are calling many times a sequence. So here I have just set a SQL file where I select nextVal for my sequence, and I run here only one client for 10 seconds. And we can see that the average latency to read from it is 5 milliseconds. I recall that here I have no cache. The reason why we want a cache, we want lower latency for that. But with no cache, we can even see that it can be worse when it runs with many clients at the same time, many sessions. And also I can show on the tablet server activity. We see the reads and writes. Here I don't have the detail per tablet, but this is my only activity that I have here. I can see reads and writes for this tablet. And that's the main thing. And I will mention an optimization that we have done on it. That's the first thing, because there is this logic with the first call or not. We read the value from the sequence, we increment it, and then we write it in 2 times, like a serializable transaction. And then when we have many sessions at the same time running, it adds a bottleneck on it. And you can see that here I have 46 milliseconds without cache. So each session will update the value and read and write, and then we have a bottleneck there. The first solution to that is to have a sequence, a cache on the sequence. And if I run the same 10 sessions on that, I will still read and write, but only once out of 100 times. And then the average latency is again lower. So that's the main thing first, running that with a cache.
Awesome.
However,
one other question from Piet is the cache held in the client session or elsewhere?
Yeah, that's a good question. And that's exactly what I wanted to mention there. I will run the same pgbench by connecting for each session. And here we will see that even with a cache, we do not really benefit from the cache, because the cache in Postgres is per connection, per session, in the private memory of the session. So here, even with a cache, because I was reconnecting each time, it takes more time because the cache is not used. And another way to show it, if I select the next value from the same session, I have numbers that are just increased by 1. But if I reconnect, just showing from another session, then I can see that it's not just the following number, because each session has its own cache. And if I look at the time, here I have a very short time because I read from the cache. Again, very short time reading from the cache. If I reconnect, this session will have to initialize the cache. So the first call for each session will be a bit higher because it has to read the tablet. So yeah, to answer Peter's question, the cache is per connection here. That's different from Oracle, for example, that's caches per server. But we will see that we have an improvement just committed about that. So this means that we should use a connection pool. So let me go back to the slides where. So using a connection pool is anyway the best recommendation we can have for anything in any database. It's even more important when distributed, and it's even more important here because the cache is per connection. So the solution, do not reconnect each time. And problem solved, except that if you start a large connection pool, then the first call from each one will have to hit the sequence. And that can be huge. You start a new connection pool, and then you want immediately the best performance for the throughput. Then many connections will hit the sequence row in the sequence data tablet, and this read and write will be in conflict maybe, and will have to be retried. So I will show first a workaround, but we probably don't need a workaround in the future versions because we have also an improvement there. So the workaround I have here, it's quite basically always the same. When we have sessions hitting the same row, what we want to do is have multiple buckets so that they don't hit the same row. So here, my idea will be to create 8 sequences instead of 1. So let's create that. I just generate the create statement, and I execute it with gexec. So that's a very cool feature in PSQL. You can just generate the SQL and run it.
That's pretty cool. I didn't realize that. Okay.
Yeah. That's really nice. Also, when you query the catalog and you generate a statement from the catalog. Yeah, that's really nice. So here I have 8 sequences named sequence, percent, and a number. We can see them here. And what I will use, I will use the fact that the next val, so to use it transparently without changing the application, what I want to do is that when the application calls next val, it will go at random to one of those 8 sequences. So I will actually overload the next val function with text, because by default it is a reg class. So if I pass a text, my goal is that if I pass a text with just a prefix like sec%, it will add a random number in front of it. So basically my function will set the sequence to read to the name I pass, except that if this name, I have my special pattern here, if this name ends with a %, then it will add a random number between 1 and 8, 0 and 7. Actually, better than a random number, I get the number from the PID of my backend, because I want to touch different sequences from multiple sessions, but one session will have the cache. There is no reason to have 8 caches for one. So I use a modulo on the PG backend.
A lot of clever tricks, Frank. Unrelated to sequences, but pretty clever. Yeah.
Yeah, actually, that's also something I did in the past on Oracle, also using that, not to read from multiple sequence, but to add a prefix in front of the sequence, because Oracle cannot shard it, distribute it by with a hash function. So that was also a trick in this case. And just for debug purpose, I show which sequence is read, and I return the name of the sequence that is built from that. So then if I look at it, setting the logs to see it, if I select only with the prefix of the sequence, it adds a number to read from sequence 2 here, and the same session reads from sequence 2. I forgot to mention it. When I created the sequence, I've set an increment by, because I don't want the multiple sequences to give the same number. So I start with 1, 2, 3 for all the sequences, and I increment by 8. So that when you read from the sequences, you will never have the same number from them. And if I connect from another session, then it will read the same call with the prefix will read from another sequence. So the idea is that the first optimizations we can do in Yugabyte is using the plenty of features that we have with Postgres. Overloading function, using the next val function, using the PID, all those features that we have with Postgres. And I run that with pgbench, so reading from there, and I log which sequence is read. Here I have many clients reading from multiple sessions. So here the bottleneck that I had on one sequence is distributed over 8 sequences, and then the latency is much better. So that's a workaround that we have thanks to many features. And there are many things that we can do. Of course, it needs some code, but only once. The application doesn't have to change with this. But of course, we can do better. We can cache per tablet server. I don't really know why Postgres doesn't do that. But finally, this is what we have implemented. It is not yet in the latest release. It's committed to the master and will be in the next release. The idea is that currently, if I reconnect, I see that I have another number with this commit. If I reconnect, if I reconnect to the same tablet server, I will just have the next number because the sequence is there. And for compatibility, we will by default use the cache at the tablet server level, but for compatibility, we have added some syntax and some parameters to be able to choose if for any reason the Postgres behavior is preferred. And another thing also, we have seen that we have those reads and writes, and that's not very efficient. So the second commit that will be in the next release is that all this logic, read, increment, compare with the maximum, and write the new value. This logic is pushed down to the tablet server, exactly like an update returning would do, but different logic. And the advantage, it will be faster because less round trip, but also no problem of retries if there is a conflict between them. So with those two commits, probably we don't need the workaround on multiple sequence in future versions.
Awesome. Pretty cool.
I guess this commit, this could also be done, the cache on the tablet server could also be done on Postgres, but there are many things that may not be optimal on Postgres, but on a monolithic, on a single server, you don't see the problem when you add latency, you can see.
Got it. So
okay, is there other questions?
Yeah, one comment from Pierre, and I don't fully understand it because I don't understand one of the acronyms here. If sequences appears as a problem in many YugabyteDB environments, you could pack this solution and make it DFLT behavior in, default behavior. Okay,
default.
I was like, okay, I thought it was some major.
When we did, it comes.
Yeah, so DFLT default behavior in YugabyteDB until PG sequences fixes the sequence bottleneck properly. So until PG fixes the sequence bottleneck properly. Yeah. So. Yeah,
for sure, it will be the default. We can even push push the fix to Postgres if the Postgres community wants it. I think it's also possible. But
it's the same code base, yeah, and open source, yeah. So totally.
Yeah. And so in general, best practices. Usually, if you have a sequence, you probably want to do a sharding on it because the goal is to distribute it. And you can declare the sequence, but the same properties, cache, you can declare it with the real SQL syntax in the create table with generated always as identity. And we can define the cache. Of course, it makes no sense to put a cache higher than 1000, I think, but with I insert throughput, why not 1000? Also, when the cache will be on the tablet server, the gap will be smaller because the reconnection do not increase the
don't exhaust
number.
Your sequence numbers and get into holes and all of that. Yeah, makes sense.
So yeah, the only thing is that by hashed, we recommend that because usually you have only point query. You don't really need a range query. If for any reason you need, we can also hash by range. And something important, there are many known problems in, especially in Postgres and Oracle, that use bit trees and heap tables. Not really with the sequence, but the fact that having an index on an always increasing value is a pattern that may not be optimized for those indexes. For example, in a bit tree, it's always a hotspot on the last block. We don't have this problem because we distribute. And also in bit trees, when you distribute, then you have a lot of block splits, and we don't have that with LSM tree, because finally it just happens. It is just happened to the LSM tree, and we don't have heap tables and bit trees. Everything is stored. All the rows are stored in the primary key, so there is no problem with the clustering factor that is also known in Oracle. So basically, you have the choice, and if you want to do range sharding, if you need to do range sharding for any reason, it is also possible. If you want to cluster the rows together, but then the inserts will all go to the same tablet. So depend if you want to distribute the rows or cluster the rows that are inserted together.
Yeah.
And anyway, in distributed system, one best practice is also to use a UID instead of a sequence. So we have seen that we can use a sequence, but at some point the sequence will take a bit longer to read the value. Even if there is a cache, the average will be okay, but some latency may be higher. If you want really homogeneous latency, then generating a UID is totally possible. We use the PG Crypto Postgres extension to generate it on the server, but it can also be generated the client side. The only thing, a UID is a bit larger, so can take a bit more CPU to compare, also a bit more CPU to generate. But yeah, that may be okay, because anyway we scale on multiple servers. So if CPU is a limit, you can still.
I think the other thing that you were mentioning, Frank, when we were chatting right before this thing started, was about how you can use, like in the range case specifically, right? Like how you can use sequence as a composite primary key second column, right? As not the first column. So
yeah. Thinking of it really as a unique number, even if you have orders and orders item, and if you just want to add an order item, you can use a sequence. You don't really need to have 1, 2, 3 in order and starting at 1 for each order if you just want a number. Because actually, yeah, that's a good point. When people really need a gap-free sequence, usually this has to be set after the commit. Because if you want no gap, then you don't want to generate a sequence and have a rollback. So you can generate the rows with something from a sequence, and then either when you read it with row number analytic functions, for example, or with a background job that renumbers everything, you can set a number with no gap, but you cannot do that before commit, because you don't know if the transaction will be committed, and then you may have a gap.
Yeah.
And then we can use that. So yeah, basically the future releases, the improvements are for special cases, really big connection pools. Usually having a cache is sufficient, but yeah, always good to optimize the little edge cases that can happen in high throughput applications.
Awesome, fantastic. Yeah, thank you, Frank. I think and I think what our users really like is that, you know, on one side it keeps complete parity with what Postgres does, et cetera. So that's really a huge plus, both in terms of existing application expectation as well as roughly how developers should think about it, right? So that's really a huge plus.
Yeah, and all the tricks are tricks that are used in SQL databases in general. You don't really need to learn something new when going to Yugabyte. The Postgres knowledge is still useful.
Yeah, and Piet makes a comment that gap-free is a whole different story problem, which is absolutely true, right? So that's different. That's a lot more logic in the database that you have to express. So yeah. Awesome. Fantastic. Thank you, everybody. Thank you for joining us. Tune in next week, same place, same time for another episode of YFTT. In the meanwhile, if you have questions, again, feel free to post them comment box or our community Slack. And thank you so much, Franck. This was fantastic. Thank you, everybody. See you next week.
Thank you.